Yes, ma'am.
Very good, very good. Next, separation of solid liquid mixtures. Very important. Now we should know what are the solid liquid mixtures, how to separate it, or any other way, like separation of solid liquid mixtures, like when we have mixed up like sand in water. So the sand will dissolve with water. We can find that sand taking sand here. When we take a beaker containing water and add few grams of sand in it, and dissolve it with the help of glass rod and leave it aside. Okay, so we find that the sand will settle at the bottom after some time. Yes or no, children? So when you mix the sand in water, it allows it to settle at the bottom. That settling the sand at the bottom is known as sediment. Okay, that sediment. We can find the sediments over here. Like solid sediments will be present at the top, and here is the liquid. So after some time, just to do the decantation process. Decantation process. Who asked me about decantation, about the rice and all? Bhumika? Neha asked me about decantation. That means when you have boiled the rice, so allow the liquid starch to separate. We just tilt the vessel so that the entire liquid will be passed out. So here we can find the sand. This is sand now. This is water. After some time, this entire thing is known as sediment. So after some time, what we do after settling the sand at the bottom, we just take the empty beaker, and with the help of glass rod, we just pour this. So we can find sand over here by easily drop by drop, the water will be taking the place in the other beaker. This process is known as sedimentation, and this is known as decantation. Yes, any doubts? Any doubts? This process is known as sedimentation, and this process is known as decantation.
That stick-like structure?
That is known as glass rod. The thing is nothing but a glass rod. So so on the glass rod, I just pour and do the decantation so that the process will be very slow. Only drop by drop, the drop will pass, so that the solid will be separated from liquid. Understand?
I got it.
Yes. Yes. This is known as separation technique. Like solid separated from liquid. This process is known as sedimentation and decantation. The process of separating insoluble solids which are heavier than liquids by allowing them to settle down on their own due to gravity is called sedimentation. What it is called? Sedimentation. After the solid and liquid, yes, Yashika, you have asked about filtration. Am I right? Filtration. So filtration is also used to separate the solid from liquid. Solid from liquid. So this is a simple setup. Filtration process. Filtration is nothing but to separate solid from liquid. Filtration is nothing but to separate solid from liquid. So this is a general setup. We can see it here. The stand is used to hold the funnel. The stand is used to hold the funnel like this. Okay, this is what funnel. So in that funnel, we take the filter paper. Okay, round filter paper we take, and we just fold the filter paper, and we need to insert it in the funnel. So when we insert the filter paper in the funnel, by using the glass rod, by using simple glass rod, we pour the how we have done the decantation. So the same way, we'll just pour the liquid along with the solid settling at the bottom. So what happens? The liquid will just pass through the pass through the filter paper, and on the filter paper we can easily find out the solid present. Why? Because solid can't pass through the filter paper because they are heavier. Because they are heavier. This process, this filtration process, this filtration separation technique is used to separate solids from liquid. Any doubts? Any doubts?
Ma'am, the decondition is used to differentiate solid from liquid, right?
Yes, definitely. Definitely. Okay. So when you go with accuracy, filtration is more accurate than the decantation. Filtration is more accurate.
I still don't understand what the thing is about the container. What is it?
This is nothing but decanted. This is solid. Solid is present inside the liquid. We are separating the solid from liquid. This is the sample. This beaker containing sample. Like sand in water. Like sand in water. For example, if you want to prepare a tea, we'll prepare the tea and we'll separate the tea leaves from the tea. Alright? So what your mother will do, she'll take the filter, and she'll filter the tea leaves from the tea. So we'll take only tea and we'll separate the tea leaves. Yes?
Ma'am, can I ask one thing? If we can directly filter this, then why are we doing this decantation? We can directly do the filtration and remove everything, right?
So for everything, this is a laboratory technique, child. This is a laboratory technique. For example, decantation is used to separate starch from rice after cooking. So your mother can't go with the filtering the loose rice with the starch. Am I right? She just do the decantation process at that time. So decantation process is not much accurate than the filtration. If you want to go with the filtration, filtration is more accurate than the decantation process. So next separation technique is evaporation. Evaporation, like...
Ma'am, can I say one thing?
Yeah.
Ma'am, I wanted to say that I know, can I share an activity based on evaporation experiment?
You want to share? What you want to share, dear?
Now I just want to share an experiment related to evaporation that I observed.
Yeah, tell me dear.
Ma'am, so in my science lab at school, we put water in a container and put salt in it and left it in front of the window for 3-4 days. For 3-4 days, and after 3-4 days, ma'am, we saw that the water had evaporated due to the sun's heat, and only the salt was left. So this is another way we can filtrate water from salt from water.
Yes. So this is happening, but it's a simple evaporation process. Like in this evaporation process, we can find that only that solid. What solid is here? What solid is present over here? Yes, clear? Here the solid is not salt water. Take the salt water in a china dish. This is nothing but a china dish. So when you have taken a china dish, take the sample in a china dish. Here, what is the sample, child? Salt in water.
Sorry.
So in the china dish, so we can't wait for 3 to 4 days. So definitely we'll go with the fast evaporation process in the laboratory. We take the china dish and we'll add the sample. What is the sample? It has salt in water. So we'll allow the sample to heat it. So when you heat the sample, we'll observe that gradually the water will be evaporated. Up to some extent, like 3/4 complete, like only the 3/4 amount of water is left along with the salt. So what, the salt is not visible, but 3/4 of water until 3/4 of water will allow it for heating. So we'll keep the china dish aside and let it cool. So after 1 or 2 days, we'll find the crystals of salt again regenerating from the what? Salt solution.
Water.
Third solution.
Yes, salt solution. So this is nothing but what we'll observe. This is about like formation of crystals again, so that we can separate the liquid by evaporation process. Only what will be the leftover? Salt. Only what is the leftover? only the
salt.
Yes. So in this way we can easily.
Ma'am, that's the same thing I shared.
Yes, yeah.
Ma'am, it's the same thing I shared, the experiment.
Yes, the same experiment you have shared with me or with everyone. But the thing is, only you have kept the chainer dish outside the class or near the window. So the evaporation process is spontaneous on its own. It takes and it's the water that evaporated. But in the 45 minutes of class in our laboratory, definitely we'll go with heating process. What is condensation? So till now we have discussed about sedimentation, decantation, filtration, evaporation. Okay, the other one is condensation. Okay, so all these things are used to separate like two different components are present in it. So what if both are important to us? So both are important to us, then we need to select the separate liquid. For example, the water vapor condenses, we receive the same water in the form of rain. Okay, especially when there is a difference in the pressure and the temperature. Okay, let the pressure and the temperature, when there is a variation or inversely proportional of the temperature and pressure, so we'll get that evaporation process and condensation process takes place. Am I right? So during how much evaporation takes place, there is a formation of clouds under high pressure. So when there is a lowering in the pressure, so you'll get back the water again from the clouds. So this process is known as condensation. But one thing we'll find here, when you have taken the tumbler containing ice water or the cold water with ice cubes, so we'll find the water droplets on the surface of the tumbler. Why is it so? Why is it so?
Ma'am, can I answer?
Yes, dear. Yes, Pragya.
Ma'am, when we evaporate something in a tumbler and then cap it with a lid, then the water is like the evaporation, the vapor in the air cools down on the lid and forms water droplets.
When the water vapor present in the atmosphere will come in contact with the tumbler containing cold water, so it loses its energy. Am I right? It loses its energy and it absorbs the energy from the surrounding. So by the process of losing and gaining energy, there is a formation of droplets on the surface of tumbler. Understood or not?
Understood.
This is because of the kinetic energy. This you are going to learn in your higher classes.
Ma'am, can I ask one thing?
Yes, Neha.
Ma'am, in the science activity that our biology teacher gave, she told us to cut a plant and cover it using a plastic cover. And I did that and I observed that there is some water vapor upon that.
Let Neha speak. Yes, Neha. Yes,
there is some water drops upon that. That's evaporation and then it condenses, right?
Yes, definitely. Because that when you covered with the cover, it consists of some moisture and air present in it. So that air and moisture will condenses. Then you can find the droplets and condensation takes place. Okay, you'll feel that the cover is empty and that plant part allow it to in contact with the air. So definitely condensation takes place. Yes?
Yes, ma'am.
Yeah. Any doubts?
No doubts.
Any doubts, Shay? No. So this is about condensation. This is very interesting, like distillation. Distillation. What is distillation? Distillation is to separate a collected liquid from a different solids. Okay, it's a distillation is used to separate different kinds of liquids based on its boiling point. For example, two liquids are present in it. The two liquids shows the similar phase. Okay, the two liquids shows the similar phase. For example, alcohol in water. So I can't separate water from alcohol or alcohol from water. So definitely I'll go with the water separation technique, simple distillation method. in this distillation method, I'll take the sample over here. So this is nothing but a sample. Am I right? So I'll take the sample over here. I inserted a thermometer inside it, and this is connected to a condenser. So to the condenser, here is one is outlet and one is inlet. Understood? One is outlet and one is inlet. So when you go with the simple distillation process, in that simple distillation process, we can find that the alcohol is having a different temperature and water is having a different temperature. And the distillation is used to separate the miscible liquids. The miscible liquids, in that miscible liquids, especially the main principle is nothing but boiling point. What is the main principle involved in it, children? Boiling point. Why? Because alcohol is having a separate boiling point and water is having a separate boiling point. So when you have taken the sample in it, the water when it attains 100 degrees Celsius, it will come out from the round bottom flask. The distillation process is to separate two miscible liquids, like they're completely mixed up, homogeneous in nature. So when you have taken the sample in the round bottom flask, this is nothing but a round bottom flask, when you inserted the thermometer and you keep on heating it. So this condenser is that one is to acts like an inlet. This is inlet and this is outlet to pass the cold water, like direct tap water. Why? Because from here we find that hot fumes of any other liquid. For example, if you have taken acetone is boiling point of acetone is 56 degrees Celsius. Okay, boiling point of acetone is 56 degrees Celsius. When the thermometer shows 56 degrees Celsius, you can find the fumes. You can find the vapors of acetone and will pass through this condenser. This condenser will condenses by passing the cold water. Understood, children? Is it okay? So this cold water condenses and this hot fumes will convert into liquid. Okay, so at 56 degrees Celsius, the acetone will be separated first. And what will be left over here? Water. So after separating complete acetone, you will find here only water will be present inside. So distillation process is used to separate miscible liquids.
In that, if alcohol and water is mixed together, we heat it, and at 56 Celsius, it gets into the vapor, and it's then condensed through the condenser, and then it is out in the another beaker, right?
Very good, very good.
No, but my one doubt is that in the condenser there is something called like cold water out, cold water in. What is it?
It's used to cool down the vapor. Then only it converts to liquid state. Na? The hot vapors, when it is cooled down, like not at normal temperature, definitely the liquid, vapors converts to liquid state. We want the liquid to be separated. Na? Am I right? Here direct liquid won't pass to the condenser. This liquid will vaporizes and pass through the condenser. So this condenser is having the, like it's a thin, you can find the thin wall inside.
Yeah, ma'am.
From this thin wall the vapors passes, and here the thick wall is nothing but from here the water passes. This water let the vapors to cool down and convert it into liquid state. We'll collect the liquid over here. Here conversion takes place, condensation takes place.
Mama, I understood well.